to understand the equation for this modulated signal, we have to write the equation for the message signal, equation for the carrier signal, and then from that we will try to get the equation for modulated signal, right? So here we can see that the maximum amplitude of the modulating signal is EM, maximum amplitude of the carrier signal is EC, while the maximum amplitude of the modulated signal will be EC plus EM. Note that this is small em, it is indicating the instantaneous value of modulating signal, and this is the maximum amplitude of carrier signal. It can be understood and in that way, like this signal is generated by adding or subtracting the instantaneous values of modulating signal in the carrier signal. That's why I am writing capital EC plus small em. This concept will be illustrated later on when we will go in detail of the amplitude modulation also. So the instantaneous value of modulating signal can be given as, we'll use this term small em. This small em is available here, right? So it is given like em sine omega m t, where this em stands for instantaneous value of the modulating signal. Modulating signal, or it is also called as message signal. This EM stands for maximum amplitude of, again, modulating. This is the maximum amplitude. While we know omega m, it is also given like 2 pi fm. It is nothing but the angular frequency of modulating signal, right? And as it is, the omega m can be given by 2 pi fm, where fm stands for frequency of the modulating signal. So it is the frequency of modulating signal, right? Similarly, we can go for the instantaneous value of carrier signal. So we will be using the term EC is equal to this EC sine, now omega c here, omega c t. Okay, now again we can write each and everything once again, where EC is the instantaneous value of carrier signal. This EC stands for maximum amplitude of carrier. Likewise, this omega c is nothing but the angular frequency of carrier. Further, we can write this omega c is nothing but 2 pi fc, where fc is nothing but the frequency of the carrier signal. I hope that you understand this. From these two equations, we can go for the instantaneous value of the modulated signal now, right? So the instantaneous value of modulated signal can be given like, let me write it first. Instantaneous value of modulated signal means this signal. So it can be given like EAM is equal to EAM, then again sine, now here omega CT, because it should be remembered that after modulation the frequency of the modulated signal is same as that of the carrier signal. That's why here I am writing omega ct. For modulating signal I have taken omega mt. For carrier signal I have taken omega ct, and as the frequency of modulated signal is same as carrier signal, that's why here omega ct is taken. What is remaining? This EAM stands for instantaneous value, while this EAM will be the maximum amplitude of the modulated signal. So let me write it once again here. EAM is equal to maximum amplitude of modulated signal. Right. Now we have seen in the diagram the maximum amplitude of the modulated signal can be written like EC plus EM. Right. So that's why I can write maximum amplitude of modulated signal is nothing but EC plus EM. Now what I can do is I can put this value of EM in this equation, so that I will be getting the equation for the modulated signal or the instantaneous value of the modulated signal, like EAM is equal to, now in place of this EAM I am writing this EC plus EM. That's why my equation becomes EC plus EM then sine omega ct. But we have equation for this EM. This EM is nothing but the instantaneous value of the message signal. For this we have already one equation, which is this. So I will put this equation of EM in this. That's why further solving I can get this equation like EC. Now instead of EM I am writing the above equation, that's why plus EM sine omega mt, bracket is completed, and now sine omega ct. Right. So further we can go and solve this, and we will get the equation in its final form. So now what we will do is we will proceed with the previous equation that we have got. We have got the equation for the instantaneous value of the modulated signal, and it was given like EAM is equal to EC, which is indicating, let me take it like this, yes, it is EC plus EM sine omega ct. And further what we did is we have placed the value of EM there, that's why we have got EC plus EM sine omega m t then sine omega c. This step I have repeated just in case you people recall all the things. Right. Now before going further, I want to introduce one more concept here. There is one concept which is called as modulation index. Modulation index. Basically, it is defined as M is equal to EM by EC, where you know what is EM. EM is the amplitude of message signal, while EC is the amplitude of carrier signal. So we can define the modulation index as the ratio of amplitude of modulating signal to the amplitude of carrier signal. So in that way, what we can write is, in this above equation, instead of EM I can write M into EC. From this equation I can write EM is equal to M into EC. Right. So I will put this value of EM here, and that's why I can get the instantaneous value of the modulated signal is like, so EC plus, now instead of this EM I am writing this M into EC. So it is M into EC, then remaining terms as they are, sine omega mt, bracket complete, sine omega ct. Right. Now further we have to simplify this. What I will do is I will take EC outside of the bracket. So EC is taken outside. So here we are remaining with 1 plus m sine omega mt bracket complete and sine omega ct. So this is simple thing. Now let us solve further. So it can be solved like this. We are getting EC, then this sine omega ct, right, plus m, this EC is taken here, so m into EC, then these two terms. So we are having here sine omega mt multiplied by sine omega ct. Simply we have solved this, and further we will go for the